Let's look at question number 1. We're looking for a tangent is going to have a vertical asymptote. And you should know where this is. You should know the graph of tangent. But if you don't, you could consider a unit circle. The tangent of an angle, the tangent of theta, is always equal to the y value of the x. So tangent is going to be undefined where x is equal to 0. So at pi over 2 or 3 pi over 2. So D is our answer for question number 1. For question number 2, again, we're looking for the graph of cotangent. And I'm going to examine this by looking at the unit circle again. I do know the graph of cotangent, but just in case I forget, cotangent of an angle is always equal to the x over the y. So cotangent will be undefined where y is equal to 0. So at 0, pi, 2 pi, and so forth. The other thing I know about cotangent is that as theta increases, cotangent is going to go from positive to negative. So between 0 and pi over 2, cotangent is positive. Between pi over 2 and pi, cotangent is negative. So if we decide to look at our choices, choice A looks okay in terms of asymptotes, but not in terms of where cotangent is positive versus negative. So that's out. Choice B is out because the asymptotes are not at the correct place. And choice C is out because the asymptotes are not in the correct place. And choice D is our answer. For question number 3, I'm going to consider the same thing. Where does cosecant have vertical asymptotes? And I know cosecant is 1 over sine. So cosecant of some angle is going to be 1 over the y value. And this will have a vertical asymptote where y is equal to 0. So at 0 and at pi, so at any multiple of pi. So it looks like our answer is C. For question number 4, we're looking for the graph of negative secant of x. And I can quickly create the graph of secant of x because I know that secant is the reciprocal of cosine. And cosine is a graph that I know well. So if that's the graph of cosine, secant is going to be this blue graph right here, right? So that's the graph of secant. And I know that secant has asymptotes at pi over 2 and negative pi over 2. Okay, now the only problem is that this is negative secant, which I know is going to be a reflection over the x-axis. So I can already imagine that the graph we're looking at is going to have one of these arches on either side of the y-axis on the bottom. So I already know that we're going to have a graph that looks like this. And again, the important thing to remember is our asymptotes are going to be at pi over 2 and negative pi over 2. And it's going to be an even function. So if we look at this, graph A is out. Graph B is out because it's not going to be an even function. If I scroll up, C looks good, and it looks like I have asymptotes where they should be. And D, that looks like the graph of secant, not negative secant. So the answer to this question has got to be C. For the next question, secant of 2x, well, that's an easy graph because we already have discussed the fact that we know what secant looks like. We know that secant has asymptotes at pi over 2 and negative pi over 2. And secant kind of looks like that. If we have secant of 2x, you know that this is going to be a real shrink, so that these asymptotes are going to be shrunk by half. So this is going to be brought in to pi over 4, and my left asymptote is going to be brought in to negative pi over 4, and nothing else is going to change. So A is out. B, it looks like we have not shrunk this at all. The asymptotes are still at pi over 2 and negative pi over 2. Let's look at the other ones. If we scroll down a little bit, C looks good, but that's not even. That is not an even function. And D is an even function, as secant should be, and the asymptotes are in the right spot. So this is our graph. For question number 6, you need to know a little bit about cosecant. You happen to know that cosecant is the reciprocal of sine, so I would always go back to the graph of sine, and I know that for cosecant, I'm going to have an asymptote wherever sine is equal to 0. So normal cosecant would, again, be this blue graph. And I'm going to have an asymptote at pi and at 0 and at negative pi. Well, if I have 1/3 x, then what I know is that this is going to be a horizontal stretching. So instead of having an asymptote at pi, this is going to be a whole lot wider. So this asymptote is going to go stretch out to 3 pi, and this one is going to be negative 3 pi. And we're going to have an odd function again. So choice A is out. Choice B looks very promising. It certainly looks as though we have asymptotes at 3 pi and negative 3 pi, as we should. So I am thinking that choice B looks good, but before I commit, let's look at our other choices. C, out. That's out because we need an odd function, and choice C is not odd, and D is way too skinny. So choice B is our answer. And for the next one, 3 secant 2x, well, I know this is going to be a vertical stretch, so I know we're going to stretch up to 3. And I know what the graph of secant looks like. The normal graph of secant is an even function. It starts at the ordered pair 0, 1, but this is going to stretch up, so this is going to start at 0, 3. It's going to go up like this. And usually my asymptotes are at pi over 2 and negative pi over 2. But secant of 2x, this is going to squish this together a little bit, so my asymptotes are going to get drawn closer to the y-axis, and they should be at pi over 4 and negative pi over 4. Again, the period now is going to be pi over 2. So let's see what we can do. Well, it certainly seems like point A looks kind of good. I would say the asymptotes do look like they're at pi over 2 and negative pi over 4 and negative pi over 4. And the vertex seems to be in the right spot, but let's look at the other choices. Choice B is a bad choice because that is not even, so we can get rid of choice B. Choice C, not even, so that's not secant. Choice D is even, and but notice this is not stretched up to 3. This stretches only up to 2. And if I was going to put in some asymptotes at pi over 4, well, maybe that would work. But the stretching is not right for D. So we need to choose. It looks like for this one, we definitely need to choose A. And for question 8, you need to know what the graph of tangent looks like. You just do, and you know that tangent has asymptotes at pi over 2 and negative pi over 2. Tangent is an increasing function, and we know that the period of tangent is pi, so this is going to be repeated. But let's just take the central region here, and I am just going to look at the choices that we have, and this is 1 to 1 between negative pi over 2 and pi over 2. So this last choice right here is our answer. For question 9, we need to look at the limit as x approaches pi over 2 from the right for secant. And again, by now, I'm hoping you know the graph of secant. You know that it is an even function. You know secant has asymptotes at pi over 2 and negative pi over 2. So the middle branch of secant looks like this. And we are looking for, get out of here, we are looking for the limit as x approaches pi over 2 from the right. So in fact, I am coming in from this direction, right? So I need to be a little bit greater than pi over 2. And what we do know about secant is that coming from the right, we're going to have another branch. So we're going to have something that kind of comes down like this. So coming in from the right, I'm going down to negative infinity. So the answer to this one, get out of here, the answer to this has got to be negative infinity. And for the last one, which is equal to tangent of x, well, one thing I know about cotangent and tangent is that they are not the same shape. So tangent is an increasing function and cotangent is a decreasing function. So I know that this second choice has got to be wrong just by moving cotangent around. That's not going to be the right answer. So I'm guessing that this answer is the first one is right. And I am going to also use the fact that I know that they are cofunctions. So the tangent of x is equal to the cotangent of pi over 2 minus x.